Now let's get to the second part of the sample problem 6a. The second part says find FG, means gravitational force between two objects, proton and electron. So this is the rule: Fg is equal to G times m1 m2 over r squared. This is the Newton's general law of gravity. So if we replace the numbers, we have Fg equal to G is equal to 6.67 times 10 to the power minus 11 times m1, mass of proton or mass of electron. Doesn't make difference which one you write them first, because there is multiplication. So we wrote mass of electron here, and then mass of proton 1.673 times 10 to the power minus 27 over 5.3 times 10 to the power minus 11 square. So again, you can multiply those two numbers and divide by this value after squaring, and then multiply it by outside of the bracket. You will get the value Fg equal to 3.6 times 10 to the power minus 47 Newton. Because they are all forces, that's why their unit are Newton. Now here we have practice 6a and section review 6.2 versus the homework. First question says a balloon rubbed against denim gains a charge of minus 8 microcoulomb. What is the electrical force between balloon and denim when two are separated by a distance of 5 times 10 to the power minus 2 meters? Now here charge is given minus 8 microcoulomb, but here we have this sign micro. What should we do? We have to convert this micro into coulomb. How can you convert micro? By multiplying by 10 times to the power of minus 6. So you'll convert micro into coulomb. So you'll say minus 8 times 10 to the power minus 6 coulomb. And R is given here. R 5 times 10 to the power minus 2 meters. So you will find force between them. But here there is an important note. It says a balloon rubbed against denim, but one charge is given here. So think about this part carefully and then try to solve the question, because there is one charge missing here. So what will you do? Second question: two identical conducting spheres are placed with their center of 0.3 meters apart. One is given a charge of plus 12 times 10 to the power minus 9 coulomb, the other minus 18 10 to the power minus 9 coulomb. Find electrical force exerted on one sphere by the other. So it says find F electrical for a sphere. We have both charges and the distance, so it's easy, just Kc constant is remained here. Third question: two electrostatic point charges of 60 microcoulomb, again we have micro here, be careful, and 50 microcoulombs, again microcoulomb, we have to convert it to coulomb, exert a repulsive force on each other of 175 Newton. So force is given here. Careful. What's the distance between them? It says find R here, be careful. So you have to change the rule. If force is given, R is asked, but in the rule R is squared also. So be careful how you change the rule and how you open the R. Now let's get to the section review 6.2. First question says a small glass glass ball rubbed with silk gains charge plus 2 microcoulomb. The glass ball is placed 12 centimeters from the small charged rubber ball that carries a charge of minus 3.5 microcoulomb. What's the magnitude of electrical force between the two balls? So if E is asked, is this force attraction or repulsion? This part is not very important. Second one, how many electrons has the glass ball lost in the rubbing process? Here you have to use the rule from first section. In the first section we solved the question about number of electrons. Second question, electric force between the negatively charged paint droplet and the positively charged automobile body is increased by a factor of 2, but the charge on each remain constant. How has the distance between the two charges changed? So it asks about what's the relation between force and distance, so you have to be careful. It says assume that the charge on the automobile is located at a single point. So you will think about it and answer it according to the relation between distance and force. We answered this before in the notes if you can check. Thank you for listening.